This is Jack Porter. I'm the producer of JaxTeaParty. This has been a series that's been around for a few years, and I'm going to show you an old video about the Septage treatment plant. There was some controversy years ago. They're paying it down now. It's going to be paid off, and it'll be a good facility going forward. But it cost about $8 million, and quite honestly, the project probably could have been done for $1 million if it wasn't for the structure of a local government, competitions between city and townships, things of that nature. I was the township supervisor in East Bay Township from 1980 to 1992. We had a pretty good relationship with Traverse City by the end of that term. But then in 1996, East Bay Township cut an essential water main for a regional water system. That was a big financial blow, not only to the city of Traverse City, which lost a lot of customers, but also East Bay Township spent $2 million to accomplish that separation. We had planned to run water out to Acme Township, even to the casino, and all those plans went up in smoke. So when the townships wanted to manage the holding tank wastes of a few hundred residences, the city of Traverse City was not going to accept that into their system. They just were not in a cooperative mood. There was just some hard feelings, I think, some damage to the relationship between the units of government. So the townships, in cooperation with the county, went ahead and built this septage treatment plant. But you got a little bit of the background, why these units of government weren't cooperating well, and why it was necessary to build such a big facility. Well, anyway, this is an old video. I hope you enjoy it. I'll warn you in advance that this is quite a boring video, and probably worse than my video of the bird feeder. But it covers, what is the septage facility and how's it used. And I thought it was important to get the information out. If you want to see the whole thing, I'll tell you what I think should be done with the septage facility. And it kind of relates to something that I heard in China about the old Deng Xiaoping when he tried to set up capitalism in Shenzhen. They said, we're communists, what are we doing, fooling around with capitalism? And he said, 不管白猫还是黑猫 能抓住老鼠就是好猫. If you want to know what that means and how it relates to the septage facility, you're going to have to watch the whole video. As you can see from these Record Eagle headlines, the septage plant has received a lot of attention, and other counties are looking at getting into the septage business as well. The septage facility had some real problems during construction, but now it's online and is taking wastes from groundwater contaminations, septage tanks, holding tanks, and grease traps. The facility is located at the top of Lafreniere Hill, right next door to the County Road Commission. The remainder of the video has to do with why the project was necessary and how does the facility itself actually work.
I'm Fred Kiesler, Health Officer, Grand Traverse County Health Department. A little of the history behind the septage plant was the need for one. Back in the 80s, early 90s, it was recognized that we were running out of places for disposal of septage, that is, the waste from septic tanks. Back at that time, the sewage treatment plant was discouraging the use of the disposal of that waste because it could cause problems for the plant. So they had gone to land application, that is, dumping the septage onto the land and then disking it in. A lot of people were concerned about that. That would be the effect on the groundwater, runoff into surface bodies of water, and just a little bit of not in my backyard issue. When there was application for a septage disposal site in the southern part of the county, there was quite an uproar of the community, the people not wanting it there. And when the townships banded together to discuss this issue of what to do with sewage, the health department certainly supported the notion that there be a common place where the septic could be disposed of.
Wasn't there a state law that changed that suddenly made it a lot more difficult to dispose of the septage?
Well, originally the septage didn't have to be incorporated into the soil as quickly and was just disposed of on the land. But then there was more requirements about the suitability of sites. So there was some change in state law.
What about the winter time? Isn't that a problem when you have, like, the ground is frozen and stuff like that?
Well, certainly in this area is the winter is a problem. And in other communities and other places, they had to go to having large storage facilities where they store the septage and then have to then dispose of it in the latter part of the year. And this was another issue, is that you still had to have a facility of sorts.
Okay, so every hauler, waste hauler, was on his own, and the septic waste isn't the same stuff as goes into the sewer plant, so they...
Right, and actually the many sewage supervisors wouldn't receive the waste because of the problems it would create for the plant.
Okay, great. Chris Boudet, you want to have a seat and introduce yourself? And maybe...
Thanks, Fred.
I really got it. I appreciate it. Sure.
All right. Hello, my name is Chris Boudet. I am the Director of Public Works for Grand Traverse County, and we are involved with the Septage Treatment Facility that is located in Grand Traverse County.
So when did this project get built, and where did you come into the program?
Well, the program actually started before it was constructed, almost completed in 2005. The project actually started in the late 1990s when townships, 5 townships, Acme, East Bay, Elmwood, Peninsula, and Garfield Township were interested in pushing forward the septage project because they saw the need to not only address wastewater issues but also address the septage issues. And since these 5 townships were the townships that were involved with the wastewater system, they were familiar with all the issues that are associated with dealing with the human waste and the kinds of treatment that it requires, as well as the kind of facilities that would be required to treat the waste.
So in the way of background, these 5 townships all had sewers and already had a relationship with the county DPW, right?
Yes, the County Department of Public Works has been in business since the 1970s, and the city, of course, has been in the wastewater business much longer, but the townships, Garfield, East Bay, Acme, Elmwood, and Peninsula, have all had their systems start in the 1970s. So there's a long history, a 20-year history, where they were familiar, adapted to, and working with wastewater systems and pumping systems and treating to high water quality standards. So as long as that was going on with the wastewater system, they saw the need that to do the septage facilities, but also saw that they had the skills to make it work, and not just from a perspective of, okay, the mechanics, how does the water flow, but also from a perspective of the finances and making sure that the facility would be financially capable.
So this is a whole new business then for the county DPW, I take it?
Yes, it is. It's a business that while most of our work, financial work, when we provide services to customers, relates in us sending them a monthly bill, it's a little different in the sense that what we're doing now is sending a monthly bill to the wastewater, the septage haulers, and it's a little different than what we're used to, but we're very familiar with the process of making payments on bills and operating the system, making sure that everything runs smoothly.
Okay, maybe a little bit about your background. Weren't you trained as an engineer initially?
Yes, I'm a mechanical engineer and worked in the construction industry and around systems similar to this for a long, long time.
So then you got a law degree?
Yes, as well, a law degree that, yes, licensed to practice law in the state of Michigan.
Okay, so you're an engineer, you have a law degree, and you've been operating the county DPW for how long?
About 8 going on 9 years, almost 10 years.
Okay, very good. We have some exhibits here. Do you want to, let me...
Actually, what I could do is, well, just leave it rolling. Okay. First diagram that we have shows a cross-section of a septic tank. And if you look over here, you can see that the waste that comes from the house, which is liquid and solid, comes into the system and will essentially deposit inside the tank. What happens over time is that there was a separation between the solids and the liquids. The liquids have a tendency to flow through the system and flow out into essentially a drainage bed that is laid out in your yard. The remaining part of it, the sludge, remains in the bottom end of the tank. And over time, the sludge will continue to build up. And what needs to happen every 3 to 5 years is that the homeowner should pump their tank. And when you pump the tank, it removes the sludge that's in the system and makes sure that the sludge does not go out into the drainage system. If the sludge goes out into the drainage system, it will plug up, and that usually means replacing the drainage system, the tile system that's out here. And when you do that, that's a fairly costly expense. You're looking at something in the range of $10,000. So certainly properly maintaining your septic system is vitally important if you're on a septic system. Most people don't know that they're on a septic system. How do you find out? Essentially, wait for a sewer bill or call your township. If the township does not send you a sewer bill, then you are on a septic system. It's important to find out where that particular system is located, so what you can do is contact the county where you reside and talk to the health office, and they can actually provide you with a map of your home that essentially determines where that septic system is in relation to your house. And once you find that, then you can dig it out and pump it. Okay.
What about protecting our environment, this visual over here?
The primary focus with the townships, the 5 townships that we talked about, Acme, East Bay, Elmwood, and Peninsula Township, was to protect the environment and make sure that the water that we have in our area is clean. The wastewater system went through a $33 million upgrade, and in that upgrade process, we made sure that we deposit the cleanest water out into West Bay that we possibly can. The Septage Treatment Facility in Grand Traverse County is another facility that does essentially the same thing. It treats water to a very high quality level, and when it discharges water that is very clean, exceptionally clean, and make sure that our environment stays very clear and clean.
Now, are those 2 plants connected?
Yes. The Septage Treatment Facility, when it discharges, it will discharge out of this building into a tank out here, and eventually that tank will discharge down a sewer line. When it discharges down that sewer line, it eventually goes to the city wastewater treatment plant, and from that city wastewater treatment plant ultimately discharges out into West Bay.
Okay, what's this on the bottom here? What is this?
This is a picture of what the standard was before we built our septage treatment facility. Basically, a hauler would drive out into a field somewhere, open up the valve in the back of the truck, and let whatever is in his tank fall out onto the ground. And go ahead.
Are you running out of land, or what happened?
Yes, we were running out of locations to do this, so Grand Traverse County and the 5 townships looked at building this facility to address the space issue, and also because there were problems with the methodology and how the waste was being applied to land. There were situations where it was applied in the wintertime on frozen ground. There were situations where it was applied on land and it was not properly plowed into the field, or it was not applied at a proper agricultural rate. In those situations, it overloaded the soil. It allowed this waste to disperse and spread across the land. And it was common for somebody's Labrador Retriever or other dog to go out and roll in it and come back into a house. So,
wasn't a clean situation?
No, it was an extremely dirty situation, and the solution for Grand Traverse County was to build the septage treatment facility and provide the cleanest treatment that we can provide, and also make sure that we keep the water as clean as we can, because we realize that clean water is a big part of our community, and it's a big part of our future economically as well as socially.
Okay, we're in the parking lot of the septage facility now. Pretty straightforward industrial style building. Well, Chris, we just had a truck pull in. Can we go take a look at it? Well, okay, so the trucks pull straight in and...
Yes.
Yeah.
We have a card that will access panel to open up the garage door.
So it's all automated then, huh? Yeah.
Then everything will start flowing through the system.
Okay, now this is a big...
I'll let Scott
This is a
explain all
holding
this.
tank. Okay, so basically the septage tank, the septic tank is what you showed us in the office.
Yes.
That's different than a holding tank, right?
Yes. A septic tank has a tank, and it also has a drain field. A holding tank is just a tank in the ground, no drain field. There's no place for it to drain out in somebody's yard.
So the holding tank is, 5 or 10 times a year you got to pump it.
Yes.
Where a septic tank every 3 to 5 years.
Yes. Yes.
Okay.
Septic tank you pump every 3 to 5 years. Holding tank, depending on usage, could get pumped every month.
Okay, so if somebody's buying a house, they need to pay attention to whether it's a holding tank or a septic tank.
If you're buying a house, you need to look at how low the ground is in relation to a body of water. If you're living next to a stream, you're living next to a lake, living next to a pond or swamp, you might have a holding tank. It's even possible to have a holding tank at very high ground, just depending on how poor the soils are for drainage. So one of the more important things to do when you're looking at a home is to go to the health department and find out whether they're connected to the sewer or they have a septic tank and holding tank.
Okay, great. By the way, your name?
Ken Stwawi.
Ken?
Stwawi.
Okay. Tell me, what happens with the sewage from the time the trucks show up at the facility to when it leaves the facility?
Okay. First of all, the material is unloaded in this building here, in one of 2 unloading bays. From here, it travels to our influent equalization tank, where it sits and waits to be processed. When the process calls for it, it's pumped from the equalization tank to this building here, to a fine screening system, and then from this building, it's pumped to our aeration tank. The aeration tank is where the bulk of the treatment happens. From here, it splits into two different directions. The clean water goes out through the membranes and into our post-equalization tank, and then eventually out into the sewer and down to the main sewer treatment plant. The other direction that it goes, the sludge that's created in the treatment process, comes back to this building, gets dewatered, and then goes to the ATAD for solids treatment.
What's an ATAD?
The ATAD stands for Autothermal Thermophilic Aerobic Digester. It basically cooks the sludge, the biological processes.
So you're trying to create something useful out of the sludge then? Or would that
Well, we're trying to... Creating something useful is an interesting side effect of it. The main purpose of it is to destroy pathogens and harmful bacteria that are still present in the sludge.
Okay, so we have basically that ugly-looking septage that we saw coming in gets cleaned up.
Yes.
At the end of the process. Okay, anything else?
Well, without going into too much detail, no.
I'm actually recording right now, but what did you say about the Bay Harbor? You may not be able to be with us for the whole tour. Bay Harbor, you're sampling a truck?
Yeah, we get loads of the water from Bay Harbor every day, and once a month I collect a composite sample from those loads and do an analysis on it.
Okay, well, what's Bay Harbor?
Bay Harbor is the water that the leachate that CMS Energy is collecting in Petoskey, that part of that cleanup.
Okay, so there was a groundwater contamination, and you're taking the water from that?
We're taking some of the water from it. It's the groundwater cleanup that all that kiln dust from the cement factory. All those years that they had just buried in the ground contaminated the groundwater. And so we're getting the best of what they have. I mean, the water's still got contamination in it, but the stuff that we're taking is the cleanest that they have.
So your processing can actually clean up that kind of water too then?
To some degree. Actually, we don't treat any of that water at this facility. It just unloads here, mixes with our water, and then travels down to the main plant for treatment.
Okay, we're recording now. We've got our hard hats on, like real construction workers.
Mm-hmm.
And
or anyone who wants to be safe.
Where is this device that you have on your helmet there?
This here is hearing protection built into the hard hat.
Okay, great. So, yeah, the high pitches could really get your hearing after a while.
Well, just any drowning or droning noises like that, like the blowers in the MBR or in the ATAD that are running constantly. I also just use it because to keep my ears warm in the winter.
Okay,
just
great.
flip it down.
Let's go. And they got to swipe a card to get in?
They do. Each driver is issued an ID card identifying them not only with the company that they haul for, but that specific driver. And when they come in, they have to come up to this card reader system and touch their card to this plate. Inside, there is a sensor that can read the information on their card and can identify them to the computer.
Okay,
when they do that, then they get a choice between which side they want to pull in on. And so it'll light up, and then they just have to hit the button, and the door will open for them. Okay. From this point, when the drivers come in, they would pull in and put their nose up against the front door.
You got a video of that? No?
Yep. And then they would hook the hose up. They'd come over here, touch the screen, and they could interact with the computer through this screen. After they swipe their card, different information will pop up. They confirm who they are, and they enter a PIN number identifying that specific card and that specific driver. as well.
And then is it holding tank material or septage material?
Right, and they have to go through, the computer will prompt them, ask them all those questions, and then they can tell the computer what they have.
Okay, great.
When they're ready, they can start. The computer will release a valve in this pipe and allow the material to start flowing through the system.
The material comes through this pipe here.
Yep, through there,
And
into the rock trap there.
It's a rock trap.
And then after the rock trap, it goes through. There's our monitoring equipment, our the little ring with the red top. That's called a mag meter, or a magnetic flow meter. That measures the speed and helps to totalize the amount of gallons unloaded. And then those three things are probes that measure ORP, pH, and conductivity, three properties that we monitor.
You're doing chemical testing at that point?
We're monitoring some of the properties of the material that's being unloaded.
Okay, good.
And then after it runs by there, it drops into the coarse screen. That coarse screen removes all the material in the water that is larger than 1/4 of an inch. Okay.
Cool.
From there, after that, all the junk that it removes obviously falls into the dumpster. Everything else goes through a pipe that's on the bottom of the screen and flows down to the influent tank. The material will come underground from that building into the east half or the right half of this tank. Our influent tank and effluent tank actually share a wall, and they're both underground. But the right-hand side of this tank, pretty much from that little blue structure over, is the influent side of this tank. Okay. And like I said, that's where it sits and just kind of bubbles. Hang on a sec. That's where it sits and just kind of bubbles until the pumps call for it, or until the process calls for it, and then it's pumped down under the ground here into the building behind us. The pipe there in the back, if you can see past there, is where the material comes in from the influent equalization tank. That brown pipe, and it comes in and is divided between these two screens. These two are called our coarse screening, or our fine screening system. Okay. They're the ones that remove everything larger than 1/2 millimeter that made it through the first screen. So it's 1/2 millimeter to 1/4 of an inch.
Okay, so we have two of these here.
Yes.
Okay, very good.
After the screens, the pipes on the very bottom, that's where all the water that makes it through the screens go, and it drops into a lift station on the back side of the plant. Like technical names, but I would at this point call the material fine screen filtrate. Okay. Because, or screened influent, because all of that material is or has been removed to a certain size. Yeah, let's go this way. I don't need to show you the lift station in this way. That tank right there, the white half of the building.
Yeah.
That is the side of that is the side of the aeration tank.
Okay, so this white, where it begins white, is your aeration tank. Okay.
Yeah. That's where the fine screen filtrate or the screened influent gets pumped into that tank with the population of biology that we have in there to do the treatment.
So you mix the air with the bugs in that tank.
Yes.
Aeration, bacteria.
Yes.
Okay. Good.
Yep. And in that environment, the biology that lives in that tank does all the treatment for us.
Okay. Very good.
Yeah. As a neat aside, I always think this is neat, but the biology that grows in that tank is not anything that we had to buy or supplement anywhere else. It's not specially manufactured. It's biology that's already present in wastewater already. Okay. It's just we just had to provide the right conditions for that biology to flourish.
This is an impressive room.
This room is one of the reasons why I have hearing protection.
Okay. Yeah. So where does the effluent come into this room?
The material that's in the influent tank, you can't see, or on the aeration basin at that point.
Okay.
Or it comes in, you can't really see it. It's behind one of those blue barrels. but that comes in at the bottom of this structure here, flows up into that header system, and then goes up those six pipes. It's inside those 6 white pipes where the membranes exist.
Okay.
They're actually shaped more like great big straws, like almost, if you could think of it like a McDonald's straw or something. And the material that's in the aeration basin goes through the center of those straws. And then the clean material, the clean water, falls out through the pores of those membranes.
Okay, so are both of these sets of pipes doing the same thing?
Yes. Just one is doing it for the east half of the tank, and the other is doing it for the west half of the tank.
Okay, and what's this thing in the middle here?
The box in the middle is our permeate box. See the brown pipes, or the gray pipes there, are the permeate that's coming off. That's the clean water that's being collected, that's falling out of the membranes. And it just collects in this box briefly before it falls through another pipe and goes out to the post-EQ tank.
Okay, and what are these big things over here, the risers?
Those are the blowers that provide the air and mixing for the MBR tanks.
And to get the bugs to grow, you gotta add air then, right?
Right. To provide the kind of biology that we want, they're aerobic biology, so we have to provide them with air.
Okay. And what's this over here? It looks like a big power supply.
This is actually depending on which part you're talking about, but that panel there, the MCC panel, MCC stands for Motor Control Center, and that's where all the power for each of the pieces of equipment in this room runs through that panel.
Okay, and then what's this panel on the right here? What's this?
That is the control panel. That's the control panel, and that is where, if we wanted to manually manipulate any valves or any processes, we could do it from there. We can start the process from there. It's where the process takes its cues from the programming in the computers and the electronics in that panel.
Okay, so but the computers run this. It's the exception when you have to use this here.
Some parts of this process are not totally automated. So some parts of it I have to come out and physically start and physically manipulate. Others are automated, and I just have to tell them to start.
Okay, we're going over to the ATAD. And what does that ATAD mean again?
Autothermal thermophilic aerobic digester. So if you break it apart, autothermal means that it generates its own heat. Thermophilic means thermophilic is a general type of biology that means that the biology that operates inside that tank likes heat, specifically heat of around 130 degrees Fahrenheit or more. Aerobic means that it's a process that is in the presence of air. And then a digester just talks about the fact that it breaks down biology and helps to stabilize the sludge.
Okay.
This is the upper half of the ATAD called our blower room. These 4 blue units here they provide air for the various parts of the ATAD. The first 2 provide the air for what we call the reaction tank, which is that's where all that digestion that I was talking about, the pathogen reduction, that's where those, where the air for that particular tank comes from these 2 blowers.
Okay.
The second 2 blowers provide air for the second tank in here. There's actually 3 tanks involved in this whole process. The middle tank in the process is just a holding tank, much like how the influent tank holds material until the rest of the process needs it. Our day tank, it's called, just holds sludge and grease until the ATAD wants it, or until the reaction tank wants it. After the reaction tank is done treating the material, it goes to the third tank, the storage tank, and these last two blowers provide air to that storage tank. This is where all the brains of the ATAD are kept. The computers that monitor how quickly the pumps are running, and the sensors that are monitoring the different processes, they all come through and are housed in this room.
What's this up here?
These are VFD readouts. VFD stands for a variable frequency drive. One way to help save power and wear and tear on equipment is to modify how hard it's working. Like the pumps, for example, don't always need to be running full out as hard as they can. And so at times, when the correct signals come from the probes and sensors and things that we have in place, when those sensors tell us that treatment is basically done, then the computers can tell the pumps, okay, well, we don't need to run as hard as we were, and so these VFDs will ramp down how hard those pumps are pumping. Downstairs is where the pumps are that do the various tasks that we need in this process. Like, they're mostly just mixed pumps because, as I said, the mixing is a very important part of treatment. So you have to have a uniform environment in the tank so that the biology can act in the same way in all parts of the tank. And it's really loud down here.
Really loud, okay.
You can get a good overview from the stairs if you like, or we can get right down on the floor.
What am I looking at here?
You're looking at the mix pumps. This is the ATAD's mix pump, the reaction tank mix pump. It's a 100 horsepower pump. It can move water in the sludge in that reaction tank very fast.
Okay. And what about this foam pump? What's that do?
Part of the mixing and the treatment of breaking down the biology in the reaction tank creates a foam. And if we just let it go unchecked, it would bubble up out of the top of the tank and make an enormous mess.
So you're pumping the foam off with this pump?
Actually, what this pump does is that it pulls sludge exactly in the same way that the mix tank does, except instead of injecting it right back into the tank for mixing, the foam pump sends it to the top of the tank to some nozzles and blows the liquid back down on top of the foam to break the foam up.
What's this do over here?
The blue pump there is actually that's the day tank pump, and that is pumping actually right now. That is pumping material from that day tank, that holding tank, into the reaction tank for new treatment. And then that final pump on the far side is the storage tank's mix pump, where the storage tank has the sludge that's already been treated. It's just turning it over, keeping the biology moving, and there actually is a little bit more treatment that happens in that storage tank.
But it's pretty much a wrap when it goes through this brown pump then.
What's that?
It's pretty much a wrap when it goes through the brown pump.
Yeah, when it goes through that fourth pump over there, it's pretty much done.
Well, thanks a lot, Ken. Is there anything else that we haven't covered here?
The only other thing that we haven't talked about is the odor control system that we have. It's actually a very sophisticated system. It's also one of the reasons why we weren't able to actually look at any of the sludges, was because they're all in enclosed tanks, and the foul air fans draw the foul air off of those tanks, and it pulls it all through ductwork throughout the whole plant. Sometimes above ground, sometimes below. The black pipes we were looking at out there, those are all odor control pipes, and it draws it all into a biomedia made of wood chips. and the moisture in the air helps to grow a culture of bacteria in those wood chips that helps to treat the foul air and remove the foul parts of it.
So we're in an industrial park on a ridge, basically, so there really isn't much trouble coming off of this plant then for anybody. Huh?
No, we don't have, to my knowledge, I don't think we've ever gotten an odor complaint out here. We can, not one that anybody's told us about. We can tell, or at least I can, different ways of knowing whether or not we're removing all of the foul air. Like I said, I can detect a smell sometimes. It's like a dry, musty smell, and that can usually tell me that we're not getting all the foul air removed, and I might have to increase the fan speeds. And because that too is on a VFD, as I was talking about, and we only have to run that as hard as we need to.
So if you smell something that's not right, then you manually intervene and turn up the pumps or whatever. Yeah,
like I said, we can get that. I have that queue of us, and like I was mentioning before, the birds, the bird population that shows up around the plant is actually one of nature's cues as to how well we're doing. When there are seagulls, we know that it's that there's not any ammonia, that it's more of an earthy type nitrate smell, and that smell is very different, especially to the birds, than like when we're not removing all of the foul air. When there's ammonia in the air, crows will show up, thinking that like a natural decay of a roadkill or something. The crows will show up looking for carrion, and so I know that when there's birds hanging out, or when there's crows hanging out on the lights out there, that's a subtle way for me to know that I have to turn up the foul air fans.
So the birds are still more sensitive than your computers.
Well, it's hard to monitor the foul air situation. Like I said, I mean, besides knowing that I've got the right CFMs and the right airflow going through and making sure it's all balanced and all that stuff, but still that VFD still needs to manually be turned up and down, and we don't want it to work any harder than it needs to, because the harder it's working, the more energy that it's consuming. So we keep it to the minimum that we have to.
Okay, well, great. Thanks, Ken.
No problem.
And thanks, Scott, when you see him. He just slipped by. So. Well, I hope you enjoyed the video. If you suffered through it to this point, I'll give you the statement from Deng Xiaoping. Actually, his remarks changed the world because the Chinese did launch into capitalism after they started the Shenzhen project. He said, 不管白猫还是黑猫，能抓住老鼠就是好猫. And what that means is, whether it's a black cat or a white cat, it really doesn't matter. If the cat can catch mice, it's a good cat. So what do you do with a septage facility? How does that relate to that? Well, I don't care what you say about the septage facility. If it processes septage, it's a good septage facility. So I think the thing to do with that facility is to use it. And I'd like to see the community make the best use of that facility that it can, and try to put some of the controversy behind us. Thank you.